Chapter 12 shows us how to calculate medications by either age or body weight or body surface area. For some medications, like chemotherapy, the most accurate determination is going to be based on an amount per square meter. It's more accurate because they're based on both body weight and height. This form of calculation is often used for pediatric patients, elderly persons, and when dosing toxic medications such as chemotherapeutics. BSA refers to the total body area that's exposed to the environment and is expressed in square meters. So to calculate BSA in square meters, we can use a math calculation or we can use a nomogram. So this nomogram is in your book on page 262. And it tells you the surface area here, which is the column right next to the last one on the right. Here's your answer. And then here's the weight and here's the height. So what you do is you take a straight edge like a ruler and you line it up with the patient's height and their weight. And then you follow it along until you get the correct one. So let's say that the patient is 60 inches tall. Right there is the 60 inches. And they weigh 70 pounds. So here's the weight in pounds. Over here is kilograms. And on the height section, the left side is centimeters, the right side is inches. So we're looking at 60 inches and 70 pounds. So you line it up so that you're right on the 60 inches and the 70 pounds, and right in the middle you're going to have basically 1.1 maybe 1.16 there. So 60 inches or 70 pounds, and we end up with 1.16 using the nomogram. So the calculation for that is the height in inches, which is 60, times the weight in pounds, which is 70, divided by 31, and then we take the square root of that. So if we were to do that on our calculator, we would do 60 times 70 equals, divided by 31 equals, and then the square root key. And look how close we got. Our actual calculation came out to 1.158, and what did we get in the nomogram? 1.16. So that's actually just rounding this to 1.16. So that worked pretty well. Now you can also do it in the metric system, in which you're using centimeters and kilograms divided by 3,600. So if we were going to do that using centimeters and kilograms, we would be looking at this side of the chart for centimeters, and we'd be looking over on the far edge on the right for kilograms. So let's say we had a slightly different sized child, and this child is 80 centimeters, and let's say that they are 15 kilograms. So they're 80 centimeters tall and 15 kilograms in weight. And when we come across here, we end up with 0.6. Okay, so 80 centimeters, let me erase this one. $80 centimeters and 15 kilograms. And when we use the nomogram, we came up with 0.6 meters square. So if we plug that into our math equation for centimeters and kilograms, it's going to be the height in centimeters, which is 80, times their weight in kilograms, which is 15, divided by 3,600 instead of 31, because this is a metric one now. And then we'll take the square root of that. So doing this on our calculator, we get 80 times 15 equals, divided by 3,600 equals, and then hit the square root key, and we get 0.577 if you're going to 3 decimal places, and that would probably round to 0.58, which you could further round to 0.6. So we're getting very close either way. The calculation using the math formula is actually a little bit more accurate, but you can use the nomogram too, and your answers are going to be close enough either way that it doesn't matter which one you use. So now let's look at a math problem using this. So look on page 266. So chapter 12, page 266, number 2. Let's do number 2 here. No, number 3. We'll do number 3. A physician orders prednisone for a child with an allergic reaction. The child's weight is 41 kilograms and is 158 centimeters tall. The usual adult dose is 5 milligrams 3 times a day. And the medication available is prednisone syrup, 1 milligram per ml. And this one, they want the child's BSA, which we can figure out in this problem. So let's say we were figuring this out using the formula. We're going to do height times weight, or weight times height, 41 times 158 equals, and since it's the metric one, we're going to divide this by 3,600. Equals, and then take the square root. And we get a BSA of 1.34. Or you can use the nomogram and you'll get really, really close to that number too. And then it says, now what we would do is, this should say that they want a certain number of milligrams per meter square, but chapter 3 doesn't do that. Or page 3, I mean. Page 266, number 3, says that the medication, the usual adult dose is 5 milligrams. So if you come back over here to page 265, there's a little thing here that says, on example 12.7, it says, if medication for a child is not ordered in an amount per square meters, a formula similar to Clark's rule may be used to calculate the dose. The normal BSA of 1.7 square meters for adults and the normal adult dose may be used to estimate the child's dose. After using the nomogram for a child, the following formula may be used for calculating the dose. So we actually did the math instead of using the nomogram. And we're going to take that child's BSA, which is 1.34 meters squared, and divide it by the usual adult or normal adult body surface area of 1.7 meters squared, and multiply it by the usual adult dose, which in this case is 5 milligrams. Okay, so 1.34 divided by 1.7 equals times 5 equals 3.94 milligrams. And that would be the strength of the medication. And it says that prednisone is available as 1 milligram per 1 milliliter. So since 1 ml contains 1 milligram and we want to give 3.94 milligrams, we're going to end up with 3.94 milliliters. And honestly, that's close enough that you could probably give the patient 4 mLs.